morning friends, myself Dr. Soumitra Shankar Das. Today I am taking classes for Department of Home Science, course is Human Nutrition and Dietetics, and today my topic is correlation. So first of all we have to discuss about correlation. What is correlation? Sometimes we may come across in some situation where in a given series of data, each individual of this series are constitute two values of the random variable. Say we have n pairs of the individual and we have n pairs of individual, and according to their height and weight is given. So that means each individual of this series constitute two values. This type of distribution are known as. Good morning friends, myself Dr. Soumitra Shankar Das. Today I am taking classes on topics correlation. So first of all, what is correlation? Sometimes we may come across some situation where each individual in a series have two values of two random variable. One is relating to say variable x, another is relating to say variable y. I mean to say, if we have n numbers of individual corresponding their height and weight is given, so that means each individual of this given series constitute two values. One is relating to the height and another is relating to weight. So such type of distribution are known as bivariate distribution. In a bivariate distribution, our objective is to find whether any relationship between these two variables is exist or not. The correlation is a technique which is used to measure the relationship between the two variables, and correlation analysis of course involving various methods and techniques used for studying and measuring the extent of a relationship between these two variables. So next is, what are the types of the correlation? Say first one is positive one. Positive means when these two values x and y are deviating the same direction. That means increase in values of x will leads to increase in the values of y. Say amount of rainfall, increase in amount of rainfall will increase in amount of yield. Similarly, increase in input material, say fertilizer, will leads to increase in yield also. So that means two variable, say here fertilizer or maybe rainfall is increased, corresponding yield is also increased. So that means these two variable x and y, they are deviating the same direction. Next is negative. When these two variable are deviating the opposite direction is known as negative correlation. Whenever price is increased, in that cases demand is automatically decreased, or sales of woolen garments is decreased whenever temperature is increased. So in that cases two variable are deviating the opposite direction and known as negative correlation. That means they are negatively correlated. If you found any type of relation there, one value is increased and other value is does not increase or decrease, it will be at a constant rate. Or you may find no correlation between them. In that cases it will be called as a zero correlation. So positive, negative, zero correlation is clear. Next is linear and non-linear correlation. Linear correlation is what actually? Increase in one value, say unit increase in one value, there will be a constant rate of increase in other value over the entire range of data. I mean to say here x value is 1, 2, 3, 4, 5, y value is 5, 7, 9, 11, 13. Mathematically we can express this data in y is equal to 2x plus 3. If x is equal to 1, y will be 5, for x is equal to 2, y will be 7. Clear? So that means unit increase in x, there will be a constant increase in y values, that is 2. Whenever this increase or decrease is not a constant rate, in that cases it will be called as a non-linear or curvilinear equation. So here we only discuss the linear one only. Next is how we can measure the correlation. So first step is a scatter diagram method. First one is for measuring. Next, our objective is to measure the correlation. First method is scatter diagram method. So scatter diagram method actually what? Whenever we plot x and y in a xy plane, the graph is so obtained is known as scatter diagram. So scatter diagram actually see, if we plot two variables x and y in the xy plane, we may find any one of this type of relation. Whenever we find this type of relation, when increasing another value, on average increase in another value will be called as a positive correlation, because we know that when x and y are deviating in the same direction, it will be called as a positive one. But on average, whenever they are deviating in the opposite direction, that means increase in the x, there will be decrease in another values. It will be called as a negative correlation. See here, increase in one values, there is constant rate of another value. Similarly here also, or maybe here also. So if we find this any one of this type of correlation, there is, this will be called as a no correlation. This indicates that whenever dots are closest to each other, a fairly good amount of correlation may be found. Whenever these dots are scattered from each other, values of correlation will be decreases. So these are nothing but the correlation. By scatter diagram method, we can at least have some rough idea about their relationship between these two variables, whether it is a positive one, whether it is a negative one, or whether it is don't have any correlation between them. But it has one demerit. See, this maybe give some rough idea about their nature of the relationship, but it won't give you exact value of relationship. So this scatter diagram has one disadvantages. Next method is Karl-Pearson coefficient of correlation method. Here he give one formula. R is equal to covariance of xy by square root of variance of x and variance of y. So this is known as Karl-Pearson coefficient of correlation formula. Karl-Pearson give this formula where R is equal to covariance of xy by square root of variance of x and variance of y. This R is known as correlation coefficient. Variance of x and variance of y, you know. Covariance of xy, that means joint measure of variability between these two variables, x and y. This has some simplified formula. If you simplify this, you may write. So covariance of xy can be written as 1 by n summation xi minus x bar into yi minus y bar by square root of 1 by n summation xi minus x bar square, that means variance of x, 1 by n summation y minus y bar, that means y bar whole square, that means variance of y. You can simplify this formula further also. So based on requirement, you have to apply which formula is useful for what type of numerical calculation is. So see, these are nothing but the correlation coefficient method. It will give you an exact value of measure of extent of linear associationship between the two variables. This is most widely used formula for Pearsonian correlation coefficient. Now we have to discuss about some properties of the correlation coefficient. One thing you have to remember, Pearsonian correlation coefficient is also known as product moment correlation coefficient. So it has some properties. The values of the correlation coefficient will be lies in between -1 to +1. This is the range of the correlation coefficient. Whenever r is equal to -1, in that cases it will be called as a perfect negative correlation. Whenever r is equal to +1, it will be called as a perfect positive correlation. If r is equal to 0, obviously no correlation between these two variables x and y. Next property is correlation coefficient is independent of change of origin and scale. I mean to say, if we have a bigger value and if we reduce this value by using origin and scale, so then new variable will get the correlation between this new variable and the original one will be the same. So this is one of the most important property which helps to calculation or computation in correlation coefficient. Next is two independent variable are uncorrelated, but the converse is not true. Means if two variables are independent to each other, in that cases their correlation will be 0. But correlation 0 does not mean that two variables are independent to each other, because in terms of expectation, we know that E of xy is equal to E of x into E of y. If two variables x and y are independent to each other, see, we know that in terms of expectation, covariance of xy is equal to E of xy minus E of x into E of y. This is the formula for the covariance in terms of expectation. But see, whenever two variables are independent to each other, in that case, E of xy is nothing but the E of x into E of y. When two variables are independent to each other, so that means whenever two variables are independent to each other, the covariance of xy will be 0. But the converse is not true. That means if two variables are independent to each other, their correlation will be 0. But correlation 0, that does not mean two variables have independent to each other. Correlation 0, that means what? That means two variables have lack of linear associationship between the two variables. But there may be relationship between these two variables in other way, maybe quadratic form, maybe in the cubic form also. So that means two independent variables are uncorrelated, but the converse is not true. Next is, if two variables x and y are connected by a linear equation, say ax plus by plus c, then correlation between these two variables x and y will be positive whenever a and b are opposite sign, and will be negative whenever a and b have the same sign. So these four properties of the correlation are very important. So there are some assumptions underlying Pearson correlation coefficient. First assumption is two variables x and y have some relation. That means they should be linearly related. This is the first assumption. Second one, they should follow the normal distribution. And the third one, there should have some cause and effect relationship. I mean to say, if amount of the rainfall is increased, the yield for a particular crop is also increased. So they have some relation. Here cause is what? Cause is increased amount of the rainfall and the effect is yield is increase. But see, if we have bivariate data, that means x and y variable, say for yield of two crops, say rice and say maize. So if we calculate the correlation between them, we will get some values of r. But in natural or common sense, we know that yield of rice does not have any relation between yield of maize. So this is our common sense that there should have some cause and effect relationship. Like increased amount of the rainfall will be increased for any particular crop. So there should be, whenever we go for calculation of correlation coefficient between the two variable x and y, there should have some relation between these two variable x and y, cause and effect relationship between these two. Next, we have to test the correlation coefficient. So for testing the correlation coefficient, we have to use t-test. This formula is equal to r into root over n minus 2 by root over 1 minus r square with n minus 2 degrees of freedom. This t have n minus 2 degrees of freedom. This r is nothing but the observed correlation coefficient and the n is number of pairs of value, number of observation. So this is all about the correlation coefficient. So thank you very much. Now we have to discuss about the limitation of R, that means limitation of the correlation coefficient. First limitation is correlation coefficient will measure only the linear association between the two variables. It does not imply the non-linear relationship. I mean to say, if r is equal to 0, that means two variable. If r is equal to 0, our conclusion is that correlation coefficient is 0. That means two variable does not have the linear relationship. It does not mean that two variables have other forms of relationship. They may be there. Sometimes it also found that two variables have non-linear relation. That means say in cubic type of form, in quadratic type of relationship, but it is found that correlation is 0. So ultimately we can say that if correlation is 0, that does not mean that two variables are uncorrelated. They may be related in some other way. This is the first limitation. Second limitation is that high degree of correlation between the two variables does not indicate that they have a high degree of association between these two variables in case of multiple correlation. I mean to say, if there are more than two variables is there, and if we calculate r between any two variables, say x1 and x2, so if we get the values of r is equal to say 0.8, 0.9, it does not mean that two variables x and y have high degree of correlation. There may be other factors, say x3, x4, other factors which influence these two variables. So in that cases, for multiple correlation, unless or until we have eliminating the other factors, that means this is the part of partial correlation, unless we have eliminating other factors, the correlation between any two variable is misleading. Number 3, suppose x and y. X is the values of, say, population of India, and y is yield of rice. So if two series of data is given for n pairs, two series of data is given, we can calculate r is equal to something. But see, we know that number of population numbers in India does not have any correlation among the yield of rice. So in that cases, if we apply the Pearsonian correlation formula, we will get some values of correlation coefficient. This type of correlation are known as nonsense or spurious correlation. Another limitation, if data are not homogeneous to some extent, the correlation coefficient will be misleading. Number 4 limitation is, if data are not homogeneous to some extent, the result of correlation may give rise to misleading conclusion. This point you have to remember. These are 4 limitations of the correlation coefficients.